I'm going to go through pretty quickly because we've got a lot of content to try to chunk through. We almost certainly won't get through it all, so I'll just pump through it. Really quickly, who we are. We're a company called Thinkst. For the most part, people will know us because we're the team behind Canary and Canary Tokens. I won't talk much about Canary during the talk, but we will touch quite a bit on Canary Tokens because it pops up. Something else to know is that this talk is almost entirely not my work. Marco's done a huge chunk of it. Most of the other guys at the company, so Azhar, Jason, Nick, and Max have done the work. For the most part, they were just kind enough to let the old guy show up and talk about it. In terms of why we're here, there's a few reasons, but probably the main one goes back to 2009. And in 2009, the big thing for us wasn't so much the inauguration of Obama. It was a talk we gave called Clobbering the Cloud. And the reason we said we were giving this talk in 2009 was, I'm not sure how many of you remember, but back in 2009, there was a lot of cloud hype, and there were a lot of anti-hypers saying, there's nothing new about this cloud stuff. And so we were saying, hey, there's some stuff you should be paying attention to here. And we did a whole bunch of attacks, like we attacked Salesforce.com, and we attacked Microsoft MobileMe, a whole bunch of players in the space. And I won't go through all of it, but most of it has held up pretty well. So if you go to the Black Hat archives, it's worth checking out. I want to touch on two attacks that we did. What you see here, if you've ever used Amazon, was we went through a lot of effort to try to Trojan an EC2 instance. And the reason we did this, in the end, it required multiple attacks. So we'd package up an AMI, and then we'd do something like racing AMIs so that it would get a low enough AMI number. And then we named it on S3 so it had an attractive name. But the end result was when someone went to Amazon's marketplace, one of the first few EC2 instances they'd see would be our EC2 instance, and it would be an evil EC2 instance. So ostensibly what would happen is you'd have all these people booting up images, but they were our images. And part of the reason we were doing this was to say that in the era of the cloud, Trojans won't be Trojans. Trojans could be entire machines or entire systems. The concept of the Trojan needed to change. And then we looked at DDoS because at the time, Amazon had this thing up on their screen saying they cater for DOS attacks. And instead what we did is we found out that when you signed up for Amazon, they'd limit you to just 20 machines. But what they didn't do was make sure that you couldn't use the same credit card on multiple machines. So essentially what we did was we took one account and registered 20 machines, and then using those 20 machines, each machine registered 20 machines, and then just grew exponentially. And you can see how this works, right? Like with even simple growth, in 6 minutes you've got that many machines. 3 minutes later you've got that many. If you're looking at about the 9th iteration, you're looking at something like 800 billion machines, just thanks to growth. But again, the important thing that we were going for was that you can't take AWS and say we cater for volumetric DOS. It's a whole new system, and attacks would look entirely different. So essentially, back then what we were saying was, this cloud thing is a little different, and it needs slightly different thinking. And so now it's almost 10 years later, and so we're doing a talk that says, this cloud thing is different, and will need kind of different thinking. And part of the reason we feel we need to give this talk is you see lots of people looking at cloud still, and guys look at SaaS and kind of look at it as just another web app. Or they look at infrastructure as a service, and they kind of look at it as hosted Linux servers in the cloud. And if you're doing this, you're missing a whole bunch. If you're a defender and you still think of EC2 as hosted Linux boxes but cheap, or hosted Linux boxes, you're missing huge parts of attack surface. And if you're an attacker, if you're a pen tester, and you're not spending time understanding AWS's guts, there's a whole bunch of fun that you're missing out on. Because there's a whole bunch of new opportunities. And so really quickly, I'm going to blitz through some of the differences we see. Footprinting, exploitation, post-exploitation, and persistence. Footprinting has almost always been undervalued. Both of us worked for a pen test company for a ridiculously long time. And if we had a 4-week pen test engagement, we probably spent a week and a half to 2 weeks just on footprinting. And that's because a large number of the companies that we compromised were because we'd find that one box on a network segment that nobody was taking care of or that people had forgotten. And what we're saying is with the current layout, with the current paradigm, with microservices, things are getting much, much harder to footprint. And it's not just harder to footprint, the responsibility lines are going to make things ridiculously tricky. So you find organizations, and they might still be running an Exchange server, or they might be running Office 365 or something like that in the cloud. But when last have you guys set up SendMail or set up XM? Okay, by and large, people just don't do it anymore. But you can bet your developers are writing code that's sending out email notifications, or people are writing code that sends off SMSs and text messages. And all of this is happening through microservices. They hooked up to Twilio, they hooked up to MailChimp or SendGrid or something like that. And all of those microservices now extend your attack surface. Okay, and it becomes really tricky because you're not really sure where the responsibility for those things live. And probably the best example of this, or one of the really nice examples of this, happened last year. I'm not sure how many of you saw this. So White Hats Nepal, which is a White Hats group in Nepal, who knew, claimed a bug bounty from Uber for being able to read Uber emails. Okay, and if you get a chance, you should go read this write-up, because the guy also posted a video on how he was able to read Uber's mail. The short version is, Uber were using SendGrid for their mail sending, and so they CNAMEd a couple of their domains to SendGrid. And inside of SendGrid, they didn't claim those subdomains. So another SendGrid customer could go in and say, I am that subdomain. Here's a webhook. Send me those mails and send me those mail responses. And SendGrid would do it. Now, it's interesting because you have to ask yourself, if this was happening to your organization, whether you'd know about it. Like, first, would you know the stuff was leaking? Second, whose responsibility was it to check SendGrid? And the easy knee-jerk answer is to say, well, we test all the stuff we integrate with. But I'm willing to bet you can't. Like, most people find it hard enough to test all the code being dev'd in-house. Now you're going to dev every API that your guys interact with. It's going to be a nightmare. The video is super interesting because the guy spends about half the time in the video explaining how he cut and paste to get an incoming webhook working. Like, he clearly wasn't super sophisticated, but he was reading all of Uber's mail. And so the question comes up, would you know if it was being attacked? Would you know if it was compromised? At this point already, I want to take a brief interlude to talk about something called Canary Tokens. So Canary Tokens is a framework, a tool that we released in 2015 here at Black Hat. And the short version is Canary Tokens. You've been hearing about honey tokens for years. Canary Tokens is a framework to make honey tokens easy and workable. Essentially, you go to Canary Tokens, you say, here's the type of token I want. I want a web bug, I want a DNS bug. You say, here's my email address, not because we care about your email address. You're essentially saying, when you get an alert, send it to me at this email address. And then you put in some kind of reminder. So if I was creating a web bug that I wanted to hide in SendGrid somewhere, I'd say SendGrid web bug. It would give me a token, I'd put it into SendGrid somewhere, and when an attacker tripped on it, I'd get a notification saying SendGrid web bug, and I'd know that there was a problem. The reason I bring up Canary Tokens, on the one hand, because more people should be using it. Literally, thousands of people use Canary Tokens. Lots of them figure out they've been owned because of Canary Tokens. It costs you nothing, it's painless, you really should be using it, and we'll give you a few instances of why you should. So if we go back to this question of footprinting, and go back to the question of, would you know you were attacked? Would you know if you were compromised? Something that's interesting is how many people today run stuff like Salesforce.com. And again, in the old days, if I was targeting your organization, I'd spend a lot of time trying to find out what your finance guys were running, what type of OS they were running, where their servers were. Now, if those guys are running on Salesforce.com, that's almost the footprinting direction that I need to go in. Because if I can compromise their accounts for Salesforce.com, I don't even need to break into your organization. I get the stuff that I want off their accounts in Salesforce.com. And the question is, would you know if they were being attacked in the cloud or on these apps? And part of the reason we showed the Canary Token stuff is Canary Tokens gives you an obvious way to play with this. So if you look at Salesforce.com, and we took a really stupid example, signing up for the default package, you can go in and customize your own homepage. And so all we do is we go to the Canary Token site, we say we're setting up a trap for Anne's Salesforce.com. Canary Tokens gives you a URL or trap URL. We then go to her Salesforce.com homepage and create a little subsection that's export all customer data, export all sales data, and leave it there. And the simple thing is that Anne shouldn't be touching that, or Anne's not going to be touching that because she's not exporting data. But when Anne is compromised, that's the first thing that an attacker is going to do. And the moment they hit that link, you get your Canary Token notification that tells you something's gone wrong here. So we're going to go quickly, because I see Marco making huge eyes at me for time, into exploitation. We're not going to touch on lots of exploitation. Marco will bump into it again. But something that's interesting with the new types of frameworks that we're looking at is that attacks and exploits don't look like they used to. You are seeing devices getting harder, but boundaries are getting fuzzier and fuzzier. We gave a talk a few years back where we spoke about the Bob Ippolito problem, which essentially is the fact that there's a guy called Bob Ippolito who is the author and maintainer of Simple JSON. And so he logs into the Python repository using his single-factor authentication and makes a change to Simple JSON. And literally squillions of people around the world all depend on that Simple JSON package. It's a dependency that most people have that they don't know they have. And for those of you who remember the left pad problem, which killed so many JavaScript and Node repositories, you know the effects of that. So what we did was we started looking around for tools we were using that had strange vulnerabilities like this. How many of you here use Atom as an editor? There's a few hands. So we use Atom pretty heavily at the office. People like it because if you're using Chromebooks, you can run it with Crouton. It's made by the guys at GitHub, so it's all new age. But what's interesting about Atom is Atom's got a plugin architecture. Okay, so guys write plugins, put these plugins up on GitHub. This work, by the way, is done by the good-looking guy in the bottom corner, so Nick's the one who owned Atom. Atom allows you to run plugins. Guys write plugins, put them on GitHub. You'll also notice some sort of social feature there, so it tells you how many times this plugin has been installed. And of course, the easy answer is you can just write evil plugins and put them up and wait till people download them. Plugins can be non-trivial and completely ridiculously trivial. So there's a plugin that allows you to cut and paste straight from Stack Overflow. So if you don't know what you're doing, you can have your editor read Stack Overflow for you. But in our case, what we did is we went for to show that two things were possible. And what you see here is with this plugin running in Atom, everything that the guy writes essentially gets ferreted off via this plugin to one of our servers. Now the reason we bring this up, the thing that you should be pondering is there's no memory corruption exploit, there's no attack on the underlying OS. Essentially, his editor is the thing that's causing him to be compromised in this instance. And if you stealing the guy's keystrokes, you can just as easily go to the next point and actually have him execute code. So on our server, we can put down commands. His plugin pulls down the command, runs it locally, and then sends you back the data. The Atom guys don't curate these plugins at all. So the plugins that your users run are almost completely arbitrary, and I'm guessing you've got no way to restrict them. The fact that Atom runs on Chromebook with a little bit of effort is also interesting. Post-exploitation, I'll move through really quickly. Something that happens a lot, someone compromises someone, then uses that compromise to read all their emails. It's interesting because pen testers do it a little bit, but in the wild, attackers do it a lot. Like I've seen organizations that get completely undone because someone was able to read their mail. And essentially, that's just a login to OWA. And again, it's one of those things that people don't know how to defend or detect against. Again, we pitch for Canary Tokens, again using the web bug. So a really simple one is create a token, create an email, or have someone send you an email saying, hey, the passwords are here or the server is here, leave it in your inbox. And the day that goes wrong, you're getting an email telling you somebody's looked at this. If you guys haven't looked at it, there's a really nice Twitter account called Tabletop Scenarios, where Ryan McGeehan essentially puts out scenarios to check for you to check whether you'd be able to handle that in your org. And Ryan put this one out a little while back, saying you're running some sort of chat, which I guess you can infer to be IRC, Slack, or HipChat. And he says you notice that messages are disappearing or getting sucked up by an attacker from your Slack. How would you respond to that? And most of you who are running Slack or HipChat should go a little cold here because almost no one I know has a good solution for it. But Alan Jones then reached out to him with a question saying, how would you detect that someone was doing this to your Slack? And between the both of them, they agreed that actually there's no way that they can think of to do this, which of course is a perfect segue for me to say Canary Tokens again. And essentially what we do here is, aside from just getting a URL from Canary Tokens, you can upload an image to us and say, give me this image as a token, which is what we're doing there. We've uploaded one called My Password. We mention it in the chat room, and essentially every time someone accesses My Password, we'll get a message telling us that it's been accessed. But what you would have seen in that picture, the stupid thing is, if I post it today, I've got to tell everyone today, hey, please don't click on this, and it's kind of purpose defeating. So what you can do just as easily is go into your own history, go into 3 months ago, and put in some sort of keyword. So go in there and say 2018 projections or 2018 salaries. There's no reason for somebody to go back and read that stuff. But what happens is when an attacker compromises someone in your org, he now searches for that keyword. So he searches for passwords or searches for 2018 projections, finds the URL, and you get your message to tell you that bad stuff is happening. So when we talk about persistence, what we're seeing a lot of, or where we think the stuff is going to go, is lots of this is going to be localized to the app itself. Meaning, if I compromise your Gmail, I set up a Gmail forwarding rule so that the stuff comes to me. I enable API access and then access you via the API afterwards. And the last thing that we think is interesting is almost the revival of self-XSS. For those of you who are doing pen testing, you know if you can find XSS, it's an okay finding. But if the guy can only XSS himself, it's kind of weak. And when we did our presentation in 2009, we showed an instance where self-XSS is actually useful. So what we did is we compromised someone's mobile me account. And what we found is if I compromised your mobile me, I could then register my iPhone to your mobile me, which sounds pretty stupid. But what's interesting is we could name our iPhone JavaScript and then register our iPhone with your mobile me, which means that every time you log into your mobile me, it tries to show you my iPhone, runs my JavaScript, and my JavaScript effectively controls what you see in your mobile me. It's interesting just because it moves persistence and rootkits to app-specific stuff. You can't talk about cloud stuff without talking about the gorilla in the room, so I will leave you with our gorilla in the room.
So the obvious gorilla in the room is going to be AWS, Amazon's web services. One of the reasons we looked at it is we use it heavily, and so a large part of what I'm going to talk about now is things that really occupied our thought, because we base a large part of our business on AWS, and it really frightens me a lot to think how we might get taken. So looking back at 2009, as H was saying, we used to think of, at least our view in that previous talk, was a bunch of hosted virtual machines. And a bunch of hosted virtual machines is quite similar to a data center full of actual hardware, and you kind of know how to protect that stuff. And so you can just distribute honeypots, for example, if that's your thing, but we know how to handle actual data centers. But sort of with Amazon and with actual cloud-based services, things have changed. So it's not just about hosted virtual machines, obviously. This is Amazon's reference implementation to deploy WordPress in AWS. And it touches 9 different AWS services, one of which is a virtual machine. So there's a whole bunch of complexity that's coming to the fore. And if you thought that Active Directory was complex, and if you sort of wrap in your mind around AD security now, this AWS ride is just getting started, and there's a whole bunch of complexity here. To give you a sense of that complexity, we thought we'd measure it in terms of functions. So if you take glibc, so the GNU libc, the number of exported functions is roughly about 800. The same thing on AWS in terms of public APIs, you're looking at over 3,000. So there's a big jump in the complexity there. We can do something similar if we look at permissions on Windows or on Linux. You're going to look at permissions across file systems and processes in the order of tens of permissions. In AWS, you're looking at almost 2,500 different permissions that can be assigned. So this really is a different kind of thing. It's a different beast. Some might even say a fantastic beast. So this needs a fresh look. Similar to those steps that Haroon went through, I'm going to go through some of these, but specifically on AWS. I want to mention Daniel Grzlak, if I pronounce that right, who's done a bunch of work in this space before. But he's one of the few people looking at AWS and AWS security. And there's not a lot of other work that's happening in the space. And so we'll go through a few of these phases and look at options that we are afraid of, that places that we might get taken. And the first one is recon or footprinting. It's the thing that Haroon spoke about as being perennially not addressed. And so it's the thing that we're going to start with. The first part of this, if you're going to be conducting recon, is to find account IDs. All right? And this is really the basis. So an Amazon account ID is quite key to lots of the types of attacks that we think about. And these account IDs they're not considered secret, but they are considered private. So Amazon doesn't suggest that you share them unnecessarily. The number is just a 12-digit number, so there's a trillion of them. And so there's a very simple enumeration attack, right? So you can start incrementing those account numbers if you choose, and you can find valid account numbers. But the way that that's going to work is we would start with an API call that will basically let us detect if an account number is valid or not. And so this is pretty basic enumeration stuff. This is one particular call. There's a bunch of them. If you make this call with an invalid account ID, you get a response like that. The same call with a valid account ID, you get a different response. So based on that one distinguisher, we can figure out if account IDs are valid or not. And that totally works, but it's just really slow, right? There's a search space of 1 trillion possibles. And so we started at one. We were trying to get a sense of the spread of account IDs. We started with one which was valid. We incremented it until we found the next valid one, and the gap there was about 32K. So there are large gaps. It's what you would expect if it's randomly distributed. We created a bunch of accounts and sort of couldn't see any correlation between the IDs. So if we agree then that it's going to be really slow to enumerate all those account IDs, how else might we find some? And it's the internet, they're developers and other folks. In general, you'll find that stuff if you just go looking for it, right? So on the AWS Forums, people post their account IDs all the time. You'll find them in GitHub repos, Stack Overflow posts. They're on Pastebin. In general, people don't seem to hold on to those account IDs particularly tightly. And it's not that surprising. As I said, Amazon advise you to not post these on their forums, but in the Amazon in their UI and also through the API, you can list AMIs, and Amazon will show you the account IDs who own all of those AMIs. So it's quite easy to pull out lists of those account owners. So that gets us access to a whole pile of account IDs, somewhere in the order of about 3,000. There's another option for this, which is interesting, and it's something that we've only hit very recently. So it's a thread that still needs pulling. But you can set up an S3 bucket, which has both logging enabled and it's limited to AWS users. And for an S3 bucket in that state, if you can get someone to browse the bucket through the Amazon console, you'll get access to their account ID and actually their username as well. But that's something that needs more pulling. I'm just going to mention it there. So if we're talking about S3, there's a well-known insecurity in S3, which is S3 bucket discovery. So the idea here is that there are a bunch of S3 buckets, and one of the features of S3 buckets, S3 is Amazon storage service, and it's a place that you can dump files effectively and have them referenced from other websites, plus a whole bunch of other things, but that's the essence of it. And so if people store files on S3, they can store them in a way that the files are accessible to anyone on the internet, so they're not protected and they don't require authentication. And if that's the case, that files aren't protected, then you can basically go looking for open buckets and download lots and lots of content. And those buckets are they have a unique name assigned to them. So it's a question of guessing possible bucket names, which you can start with domain names, or you can look on websites to see if they reference S3 buckets. And as I said, this has got a whole bunch of attention. So recently there was a case where a defense contractor left a whole bunch of classified info on an open S3 bucket, managed to embarrass his company. And this has been, there's a whole bunch of work that's already been done in the space. The reason that I'm touching on the S3 bucket, the open S3 buckets, is because there are similar services in Amazon that can also be left in an open state, similar to the S3 bucket. And one of those is the SQS service, the simple queue service on AWS. So SQS allows you to create a queue, a programmatic queue, the thing that you put objects on and take objects off through an API. And the queue is addressed via a URL, like it's a web accessible URL. And these queues can be configured to be open to the world. So there's like a checkbox that you hit, and now anyone can access that queue. And what makes a queue URL unique is a combination of the account ID plus the name that's been given to that queue by the account owner. We already have a bunch of account IDs, right? So we've already got our 3,000 account IDs. In terms of queue names, what we need to do here is we need to start guessing queue names. And our options are we can guess names like test queue, look at various samples of code and see if people are cutting and pasting code, they're likely to keep queue names. Or again, you can head to the AWS Forums and see what people are posting there, and you'll find reference to queue URLs that look quite useful. So a potential queue URL might look something like this. And as you can see, so the whole row of X's on the second row on the left, that's where you would put an account ID, and after that comes the queue name. And again, this is a pretty basic enumeration attack. We went through this. We found open queues. We found queues referenced in the AWS Forums that were also open queues. And at that point, if those queues are production queues, you've now got insight into production data. I will point out that we didn't find a lot of them, so it's not an issue with the same prevalence as open S3 buckets. But the question for you is, if you're running SQS, how are you going to figure out whether your queues are open? It's that part of the cloud stuff that becomes, for me, quite frightening, given that we run some of these services and we don't have a handle on it. So if we then turn our attention to compromise, again, this has received a bunch of attention. One of the main ones has been around credentials and API keys, so I'm going to go through it pretty quickly. Credentials often if you're going to steal root credentials, it's an email address and a password. That's a phishing attack. The API keys are the more interesting one, and it's the thing you've probably seen before. So the idea here is that someone takes an API key which gives you access to the Amazon API, and the keys are left either in a GitHub repo or they're embedded in a mobile application which gets disassembled and the key gets recovered. So the idea of these long-lived API keys is problematic, and Amazon looked to address it through temporary keys. So the idea here with temporary keys is that your keys are only going to be valid for some fixed period of time. So that could be 6 hours or a few days at most. And the way that those keys get used is that you would take an EC2 instance and assign a role to it. Right? But this means that you can't embed keys inside of an application, or you can't embed them inside of your source code. So this is definitely a step up. The one thing to point out with the temporary keys, though, is that there's nothing that ties a temporary key to the instance that was granted the key. So if you can steal those keys, they can be used elsewhere. There's no limitation on how the keys are used. And there's one other aspect of authentication that I'll touch on, which is identity documents. And this is something I haven't seen referenced previously, but there is a way that you can authenticate to the Amazon API using a particular authentication token called an identity document. It does only work in CloudFormation, so if you know AWS, you'll know CloudFormation, but it is just a sort of a curiosity. You don't always need API keys to hit the API. So if we're still looking at the ways that we might be compromised, and this is one of the ways that concerns me, you can share without too many restrictions particular resources between Amazon accounts. And one of those are AMIs, right? So the image of a virtual machine, which you would boot up. So typically you would create an AMI that captures the kind of instance that you'll run frequently. And you can have a library of those AMIs. But you can also share those AMIs with other people. And Amazon places no limits on who you share with, or from what we've seen, how many times you can share an AMI. So we've got AMIs we've shared with our 3,000 accounts, haven't hit any limits there. And the thing that concerns me with the shared AMIs is that from a victim's perspective, the AMI shows up in their private list, and they've got no way of removing it from that list. So that AMI, once it's there, you can't remove it. You don't get notified that it was put there, and you don't have to accept it. So the attacker can effectively either target you specifically with a name that is, you get to name the AMIs. And so they can provide a name that's particular to your organization, or they can provide a generic name like Amazon Linux Preview 2018 or something like that, and hope someone runs it. And at that point, they've got code running in your organization. But with code running in an organization, one of the questions that will occur is what permissions does any given set of credentials have? And as I said, there's almost 2,500 permissions, 3,000 API calls. Determining if a particular key has got access to all of those calls is easy if you've got access to the call which is show me my policy. So if you can list your policy, which is effectively your permissions, then it's easy to determine what you can and can't do. But if you don't have access to that, all's not lost. The simple approach here I'm going to give you the sort of run through of the approach, which is let's try all 3,000 API calls and see which ones succeed. And if they don't succeed, well, we know we don't have access. And if they do succeed, we have access. So it's quite easy to also enumerate the permissions, even if you don't have access to the policy document. The one thing I'll point out here is that when we do that permissions enumeration, lots of those calls actually have side effects. So you can't call terminate instance or delete S3 bucket because you're going to be wiping stuff that may be sensitive. Instead, what we do is we limit it to only those APIs that don't have any side effects. There's some particulars about the tool where we brute force parameters which make it interesting to write, but the sum of it is we call 800 APIs and we see which ones of those succeed or which one of them don't. That is curious. Right. So the next step then is going to be lateral movement. Again, Daniel Grzelek had some work on running scripts inside of instances, but some of it of his particular approach was that you have to stop and start instances in order to run shell script on those instances. We took a stab at seeing if we could make this happen without having to stop and start instances, and the answer is you can. So does anyone here use CloudFormation by any chance? Show of hands. So there's people here who are using CloudFormation. If you're using CloudFormation, the thing that it turns out, so CloudFormation, real quickly, is Amazon's, one of their orchestration technologies. You can set up a template file which has a whole bunch of resources in it and then deploy it as a chunk. So you can say deploy WordPress with a security group and an elastic IP and all of these other resources in one go, and you can back them out at the same time. So you can delete a stack and have all of that stuff removed in one shot. And so what it means is that these things all happen through these CloudFormation templates, and it turns out that those template files can be easily modified. So if you have a running CloudFormation stack, you can pull down the template file for that stack, modify it, redeploy the template, and the whole thing executes again. And that includes, in this example, we've included some shell script that runs from the template. In order to do this, you need to have permission to reapply a CloudFormation template. But it's not different from actually deploying a new template. So again, coming back to how would you figure this out? If you're looking in your logs, in your CloudTrail logs, there's not going to be a big sign saying someone's changed your CloudFormation. You're just going to see a new change set, which is what you would see on a fresh deploy as well. But there's more to CloudFormation. And so what I've just spoken about is actually modifying the template itself. But because CloudFormation is now a new layer, this orchestration layer, with a new templating language, we have to see if this templating language also has potential issues. And what we've got here is Facebook's default app, their sample app for CloudFormation. And this thing is basically trivially vulnerable to injection if you allow untrusted parameters into the template. Note, I'm not saying if you allow someone to change the template itself, just if you allow untrusted parameters into the template, this particular CloudFormation file will leave you vulnerable. And again, how are you going to know about this? In terms of lateral movement, I'll talk about one other option, which is simple system management, SSM. In short, this lets you, or this is Amazon's solution for monitoring multiple servers across data centers, not just in EC2. So if you're a pen tester and you see SSM enabled, like happy days, you're going to enjoy it. By design, it lets you run commands on the machines that it manages. So we then look at privilege escalation. I'm going to not talk too much about IAM. Like IAM, if you've got access to it, you can do anything in an account. The same for roles. So like there's a whole separate discussion on roles, which we're not going to include here, but roles are always useful. The one thing that I want to touch on with privilege escalation is the idea of tag creation. So there's this pattern in IAM policies, permission building, in which resources get tags. So you can tag an instance with the dev environment tag, or you can give it an owner tag or something like that. And you can then build your policies around those tags. But if you're relying on tags for building your policies, then the permission to create tags becomes a very important permission. And so then that thing, if you do see tag-based policies, create tags, users with create tags become much more important than you would have thought otherwise. So if we turn to persistence, there is some previous work in this space. Our take on this thing was we use Amazon Lambda or AWS Lambda. And in short, Lambda lets you execute a chunk of code, Python or whatever, in response to particular events. And so the way we persist in an account here, and this is a toy example which shows the idea, is we have a Lambda and we have an instance, and they monitor each other. Right, so the instance is seeing whether the Lambda has been deleted, the Lambda is seeing whether the instance has been terminated. And so when that happens, what we've got on the left is a Lambda that is being deleted, and you'll see we refresh the page after it's been deleted and it's recreated. And on the right-hand side, we've got our instance, which we're going to try and terminate. So we terminate the instance, but the Lambda at this point picks up the terminate event and will restart the instance. So you've got this symbiotic relationship between the Lambda and the instance. When the one's removed, the other one restarts it. There's some technicalities to get that right, which make it cute. But you can take that, you can extend that idea to multiple Lambdas, multiple instances, and so on. But the one that really scares me is the idea of subverting Lambdas that are already in place. So we don't create a new Lambda. What we do is we take a Lambda that's already there, that responds to events. We compromise an account. We look for the Lambdas that are in place. And we just modify that Lambda. So we change it. So instead of just returning the original hello world, what this Lambda will do is it will write out a set of temporary credentials to an S3 bucket under our control, and then return hello world. So from the user's perspective, from the system perspective, it behaves completely as it used to behave, except from our perspective, we also get credentials whenever this Lambda is triggered. And as someone who uses AWS, like, how do we know that that's happened? Like, good luck with that. There's no code signing, there's no ability to detect that those Lambdas have changed, except if you're pulling down the Lambda code. And if you're monitoring CloudTrail, you'll see that there are events that happen. But if you're deploying Lambdas frequently, you expect to see those events. I'll touch on lockout as a persistence mechanism. It's possible to create policies that prevent the admins from accessing their own resources. And that's not a permanent solution to persistence, but it can buy you time. So a policy like this will prevent someone with full admin access from actually accessing the instances that you care about. To recover from that, you're going to need to go to root account credentials, which may take a while to get. So the option of, but the thing I guess which is more interesting for me in terms of persistence is the idea of federation. So Amazon lets you set up trust relationships between accounts. So, and again, this has been done, some of this has been done before, but we can set up a relationship between two accounts that gives the attacker's account access to the victim's account. So even after the attack is gone, they still have this trust relationship in place, and that would give them then access. They'd be able to assume a role in the victim account. The slight twist to that is you can reuse an existing role, so it just means that things don't show up as cleanly. So you can take a current role, add a trust relationship to that role, and then continue from there. So all that you'll see here is a modification, but you won't see a new role being created or a new user being created. But the one for me, which is the most powerful from a persistence perspective, is organizations, which are the thing that Amazon have added most recently in November last year. So organizations allow you to create a sub-account. And what makes this, I guess, a little bit funny is if an attacker compromises your AWS account, they create a sub-account from it. They have full access to the sub-account. So even if they have limited access in the primary account, the parent, in the sub-account they have full access. So they get to launch whatever services they want. But the thing that makes it particularly tricky is that in the sub-account, the parents or the owners of the parent account can't remove the sub-account at all. Like, they can't. You have to contact AWS support in order to remove that sub-account. So the attacker creates a sub-account, does whatever they want to do, and the owner of the main account is helpless until they get assistance from the AWS support. And the reason for that is there's no payment mechanism set up in the sub-account rather. And so AWS won't let you disconnect and you'll just get an error. And then the last thing we'll talk about is login disruption. There's been some previous work on this. The one twist we'll add to this is what we found is that it's possible to modify the logs and not have the validation completely scream. So you get a small warning, but not a cry that things have gone completely pear-shaped. And the basis of this is effectively when you set up CloudTrail logging and you set up validation on those logs get validated, or they get hooked together through digest files, and those digest files are chained together cryptographically. What we can do is we can modify some of those logs after they've been written. Of course, this changes the digest, so this means the digest shouldn't validate any longer. But at that point, we modify the CloudTrail to no longer validate, and that creates a break in the chain. And so there's a new chain that gets created, and with a break in the chain, we're now able to delete the old digest chain. And so from the validation perspective, what you see is there was effectively a stop-start in the login, but you don't see that the logs were modified. So these are the services that we touched on EC2. These are the services that we haven't touched on EC2. Like, there's a whole lot of fiddling that still is left to be done here. And there's this sort of question around what's an alternative way to deal with this complexity. We did a whole bunch of work on BeyondCorp for this, but clearly that's not going to be included in this talk. But there is a whole bunch of stuff that I think can happen also on the BeyondCorp side.
So we'll include the BeyondCorp stuff in the slides. We're just not going to have a chance to go through it now. At this point, the question is whether we're saying that all the stuff is gloomy and hopeless. And for the most part, we're saying no. What the cloud and what this type of paradigm does give us is a concentration of skills and a whole bunch of instrumentation. There's a whole bunch of useful signals coming out of this. The problem is most of us are not aware of them and most of us are not looking at them. We're big proponents of simple, dirty tricks to detect attackers in your network. It's one of the reasons we like Canary and tokens. But for example, if you're not talking about cloud infrastructure, like something I always talk about is saying to guys, write a throwaway piece of PowerShell that tells you when new admins are added to the admin group. Like we've done pen tests for years where only after the report goes in do people know that you added yourself to domain admin. It's ridiculous. And what we're saying is once you start looking out for those tricks in the cloud, you should be able to do pretty much the same thing. So 2 examples that we look at super quickly, both done by some of our guys, are DriveWatch and AWS ID tokens. DriveWatch is fairly simple. If you're running Google Drive in your organization, there's a whole bunch of docs that are living in your drive. Google instruments access to that drive pretty richly. So if you tap into the API, what you can get an idea of is Bob has access, or Bob has his Google Drive. Bob has 100 docs in his Google Drive. Today, Bob read all 100 of his docs. Okay, that sort of behavior is going to happen when Bob gets compromised. So if you go to GitHub, you'll be able to pull DriveWatch, which essentially has 2 ways of working. If I skip really quickly, there's the simple mode, which says, watch this G drive and tell me when a file is accessed a certain number of times. But the other one that's more interesting is called threshold mode, where Drive will keep 180 days worth of history for people accessing their drive. So what the script will do is access that history and say, on average, Marco accesses 20 files a day. Today, Marco's gone 20% above his threshold for file handling in Google in Drive. So right now, it'll spit out to console, it'll kick an alert to you via syslog. And again, much like the PowerShell script to tell you that someone's been added to the admin group, you will get a false positive with it occasionally. It's fine. Like if you can account for the fact that Marco's got a big project on, or someone occasionally does it, it's not a big deal. What you want to know is when someone's been compromised and someone's about to walk out of the door with all of your data. Marco spoke a lot about AWS ID tokens. If someone's got your tokens, they've got access essentially to your data center in the cloud. Again, Daniel Grislick and Dan Bork from Atlassian are about to release a tool that allows you to create honey token AWS IDs. What you're going to end up doing, so they'll release it in the next few weeks. Essentially, they give you CloudFormation. You create an AWS account. It then stands up in your AWS account. You ask for IDs. It gives you IDs. And the logic is that you seed these IDs so that you can know when you've been compromised. We've done pretty much the same thing and thrown it into our Canary Tokens framework, which is live now. I say we loosely. It's done by Jay there, trying to show that hacksaws don't have to be soft. But essentially, if you go to Canary Tokens, you can choose AWS ID. Follows the same principle. Put in an email address to be reminded. Put in a memo that says, here's where I'm leaving this AWS ID. It then gives you AWS ID credentials. And the moment someone tries to use those credentials using some sort of AWS call, you get your Canary token alert that tells you that that ID has been compromised. The guys from Atlassian have found huge compromises of third-party providers using exactly this. So they've put AWS IDs out in the wild and found that the AWS ID that they stored with provider A has now been accessed, giving them a good indication that provider A is actually compromised. So a really quick wrap-up. Something we should know, despite doing this for years, Marco and I are still really bad at managing our time. Sorry about that. The attack surface in the cloud is not just equal to machines that are hosted far away from you. There's a fair amount of signal for you to work with, but there's also a large amount of noise. You'll notice for almost everything Marco said, he said, well, you'll see this in your logs and you'll see that in your logs. But realistically, most of the guys who I know, like with a few exceptions, don't even pick up start-stop instances in their cloud. So when Marco was doing the testing, he was like, but you'll see a stop event. And in truth, for a long time, we wouldn't have picked up machines starting and stopping in our cloud because we've got hundreds of machines and they do it all the time. There's lots of fun for both red and blue teams. If you're a blue teamer, go check out Scott Piper's flaws.cloud. It'll teach you a whole bunch of stuff. If you're a red teamer, you should be spending time here because there's a whole lot of ownage just waiting to happen. We've been told we don't have time for questions. Shout at us on Twitter. Tell us why we're wrong. Thanks a lot for your time.